Okay. Um, well, to introduce myself, my name is Mark App, and I'm the founder of the Great Lakes Data Watershed. That started actually as part of the Lake Erie hack in an Erie hack in 2019. And the whole focus was to create a place where it was easier and much more accessible. We can get much better access to our water quality data. So that's kind of our origin, and I'll tell you a little bit about that as we move on. But with regards to the hack, our focus is this challenge. So we believe that there's a lot of data that's out there already publicly. Now, it's not necessarily easy to get to, that if it was properly visualized and controls put on it, that it could add a lot of value to that data and to the water community. So our data visualization mini challenge is about focusing on existing data that's out there that's somehow available to get, and to build a really powerful dashboard or dashboards that allows the community to interact with it, allows people to learn from it, provide some insight into it. And if we look at our, just 1 second here. So if we look at this, the challenges that are related, there's also a challenge that has to do with 1 second. Data mining challenge. And that one also, we consider as kind of a data visualization challenge. And those challenges can be found at that link. Now, if somebody works on dashboards or this kind of work for the challenges, we're prepared to provide this kind of support, our company. And that would be, I'll help them set up a development server, do mentoring for 3 teams, conduct these workshops about how to get public data and build dashboards, and also to provide open support sessions. And my contact information and also the information regarding the Great Lakes Data Watershed link is found there. Second, I'm bringing up the screen. So this is the Great Lakes Data Watershed, and I'm not going to spend much time at all here, but it kind of indicates what we're talking about when we talk about a visualization. So there's a bunch of, this is gldw.org, and these are all little dashboard components that provide some meaningful insight into the data that we have in the lake. For example, the USGS salinity map displays actual salinity values for the Great Lakes sensors that come from USGS. And you can pick some and compare them historically to see how the salinity has changed. So that gives an example of a kind of dashboard that has some useful information, either educationally or from a standpoint of providing data that might give you insights into a problem in the lake. So we're prepared to help people build dashboards. There's no necessity to use any of our existing technology or anything like that. But, and we're here to help. So it all starts out, in this particular presentation is about how do you get data. So what is a REST API? Because a REST API is the way we typically get data. Starting out with the 2 words, REST and API, what does that mean? Well, an API is an application programming interface, and believe me, they've been around forever, and there's different technologies that allow them to be implemented. But what they allow is applications to directly interact with other applications. So I can, control an application, say it's a employee database application. I can add employees to it through these defined protocols and structures. Now, what's new about what we're doing now, the REST API, is an API that's made to work over a network and uses primarily HTTP protocols. There was a previous version of APIs that worked over the network called SOAP Web Services, which I'm actually fairly familiar with, and they're very complicated and probably more defined, but very much more difficult to implement than REST APIs. And the question you may have is, why do you need an API? Well, if you wanted to create, suppose you wanted to create a map or even a web screen that displayed a map or plots that's very interesting, you'd have to go get the data somewhere. And that actually you use a REST API to get that data. So your web page is actually kind of an application talking to another application and getting that data. Suppose you want to perform some kind of automated analysis. So you want to keep analyzing data from the lakes. It's real time. You need to get that data somehow. Consider also that you might want to monitor a parameter and do some kind of alerting if something occurs. So you know if the flooding or the level of water in a river is rising, and at the same time it's above a certain level, you want to maybe get a notification. All these things require that you go out and get data from a source using an API. Now, APIs, by definition, REST APIs, they can send data to applications too, and they can control applications. But in reality, we're focusing on one part of that. We're focusing on the part where we get data from an API. So the REST API, so this is the way that we kind of get data from a system. It typically uses the GET method. So if you're familiar with web methods, the GET method is one of them. And it uses a GET method to retrieve data. We also have some that use the PUT method. It works over a network. It's the most common type of API used over the web. It's much simpler to use than web services, which I mentioned previously. And it typically uses standard URL parameters to qualify the request. Now, when it acts, when it goes out and you call an API, what does it send back? Well, it can send back 3 different structures: fixed structures, delimited structures, and structured data. I'm going to skip ahead here because I think this would be useful. And I'm going to ask you, if you're on the call, I'm going to put these in the chat window. This is kind of a little bit of a exercise. So these are different APIs of different sources that we're familiar with that, see, I'm trying to find my chat window, just a second. So here's different APIs that are out there. Now, these are some public APIs that are provided by different important sources of water data. So one of those is the USGS Water Service. One of those is the USGS Water Watch, which is the USGS also, but it provides different types of data. One is the National Data Boy Center, which is more actually is data from buoys on the lake. And the next one is Great Lakes Data Watershed, which is the system that we run that consolidates this data and provides data from it. So I'm going to ask people, if you're sitting at a computer, maybe just take one out of the chat and click on it, or put that URL in your browser and see what kind of data you get. And then we'll go back and kind of look at, you can try all 3 or 4. So go ahead and give it a shot there. And I'll do it at the same time. But please get your hands, give it a try, because I think you'll find it interesting.
Yeah,
So here
I'm
we
not,
go ahead, Chad.
I was just gonna say, so you have different data points in here, like yours has the flow rate, which is all the location data, the different sensors. This NOAA one has temperature of all the different sensors. And this water watch one, I see the must be a depth reading.
Yeah. Well, the Water Watch has some of the data that USGS has, but it doesn't have all the water quality metrics. So USGS Water Service has things like phosphates and stuff where they're available, turbidity, whereas the Water Watch is the summary just for flow data, for the flow and stage data for the different APIs. So good, I'm glad you gave me a shot. So let me back up a little bit. Did you have any questions, Chad, at this point?
Not on this stuff, but once I have some questions on GIS mapping and what kind of parameters of things you have.
Okay, all right, let me go back up and maybe we could take that at the end because it may be not something that I would need to probably get some details about those APIs. I'm not specifically familiar with the ones you might be talking about there.
Before you go, could you repaste that USGS link? I can't seem to, it won't let me copy it, and it's not a hyperlink in the chat, so I can't get in there.
Oh, okay.
Copy, paste doesn't work. It's weird.
I think it's actually wrong. I don't know how it became wrong, but let me paste it again.
I can type it too. Didn't even occur to me.
It's a long one though.
Yeah. All right. There we go. Thank you. Discharge cubic feet per second, gauge height. Where's the particle and turbidity data you mentioned?
In this particular API, you have to specify it. So I'm not actually asking for those parameters. So okay. In the case of the like 60 is stage and 65 is height, and like particulate is 800 something. So you have to request what parameters you want.
Oh, some of the sensors have them and some of them don't. I see.
A lot of them don't. So
yeah.
There's a lot of water quality data there. So, since Chad, I haven't seen anybody else join. So if you want to make this more interactive, that's great. But I'll just continue. But if you want to stop and head, I would, if you had specific questions about an API that I may not have worked with significantly, it might be something we could follow up with, because I do want to help people get plugged into these APIs one way or the other. And we're, quite familiar with how the tricks of getting that to work. So looking at, we talked about, we have different return types, and this is what I wanted to, if you tried that little experiment of clicking some of those really open APIs, you get to see, what kind of different return types are coming back. So USGS has a lot of variations and different things, and they do a really pretty good job. But the first one you see here is a fixed return type from USGS. So every field has a particular size. It's in a certain position. And in this case, it's talking about the station. There's a station number here. And, this is a description of it. And there's many of these tables, so there's more than one of them. And this is their RDB format, I believe. So if you take the NDBC, they're a little more primitive, and what they have is this kind of format where you can go and get a particular station. So when I entered that, there's actually a station number, and this is just the data from it. And we see it's kind of fixed with a column header, and this is average. Let's see. Well, that's pressure, degrees. I'm not sure which. Well, a degree C is the air temperature. But all those things are. It's kind of cryptic, and it's in a fixed format that you have to get through. In the case of USGS, in this particular case, and there's other USGS returns every type of data sometime or another. It's using comma delimited. So this, everything, all the fields in here are separated by commas, and the first line tells you what those fields are. Any questions on that? And you look at that if you try them out. Now, GLDW is a little bit different, and that's our thing, where we take the data from these different sources and we return it as structured JSON. So in this case, the data is returned as JSON, and we see it's some of the same data, but it's just the data in a different format, and with the timestamp and the longitude, latitude all kind of together. There's also, it's common to return structured data as XML. And here's XML structured data returned by USGS. And one of those URLs that we gave you, if you give it an XML as the format, it will return this for the data. So at least with USGS, you have some variations in how you can get data back. A lot of other sources you don't, and you have to deal with what you're getting from them. Now, here's the APIs again, and we'll notice, all of them, there's similarities in that when we pass the data in, there's a particular URL with a path, and it uses URL parameters. So it says the format is RDP-C and the site equals and the status. So they all of these use URL parameters. The GLDW does also, but it's optional. NDBC doesn't. So in the case of NDBC, it's going and saying, okay, just give me this file. It writes these files out of this data, and it just sends the file back. So it's rather simple, but you need to know what that station 5-letter code is. So it's kind of old school. Another thing is, if you want to learn about APIs and stuff like, there's a test page here where USGS lets you actually design your query based on what you want. So there's a big page, and it basically can teach you an awful lot about different types of formats there. Here it is. It actually clicked when I picked on it. So you pick what you want to get, and you can say what kind of format, and there's a lot of options, tons of options. And it will build a query that you can use, and you can run that query, and you can try the query, and you can actually run it, or you can generate the URL. So very good place to look to kind of get an idea. There's a lot of similarities, and a lot of other places that provide APIs might provide this kind of thing to help you do it. Now let's, so the question is, this all looks pretty straightforward, like you put something in, it returns data, you have to figure out how to rip through it. But there's a couple of things that make it really challenging in some cases. So one of those is metadata. Now, metadata is really important. Metadata tells you all the things you need to know about the numbers that have been returned by that station or whatever. Things like the name of the parameters, the units, the organization. It might have information about who's responsible for that data, the quality of the data, the hydrologic unit code, the station name, all those kind of things. They're not the data itself, so they're considered metadata. Now, inherent, they wouldn't necessarily make it difficult, except a lot of times you need to know a lot of that metadata to make any use of the data. So imagine you wanted to go and get data from USGS and wanted to plot it. You might need to know what this, you might want to include the station name. Well, that's not right in the data. It's metadata. You have to get it from somewhere else. So if we look at some of the URLs that we used previously, many APIs require you process metadata to really make any kind of interpretation of it. So in the case of this query from to water services for USGS, not only did you need to know the metadata which of these parameters, which are their code, so you needed to know that 60 was stage and 65 was depth or whatever, or vice versa. But you also, when the data comes back, it may come back with a lot of little tables that have metadata. So we have data, if we want to know what the name of the station is or how we label it, we get this table back and we have to do it. So what does that mean? It's not easy to just go out and get data and then have a computer plot it and do automatic stuff with it, because there's a lot of information that's in different places. And you might need to know some of that data beforehand. Now, if you're just trying to get data, say for one station, and you want to get the depth data, you can look up the metadata information and you can put the right parameters here. But suppose you wanted to plot all the data that's associated with all the stations that you had available, you don't know what to request. So the metadata is both a problem when you try and do a query, and also when you get the data back, because when you get this formatted data back, there's a little table here you have to look at, and then there's another little table and another little table to kind of put it all together. GLDW and other structured forms and does not require any metadata to plot or map it. So that's one of the advantages we have. If you go to GLDW and get the same, if you get the same USGS data, it's already kind of structured this in a way that you can use it now. You don't need to go and put together metadata. So any questions at this point? So one thing that makes it difficult is metadata. The other thing is makes it difficult is some aspects of security. So these are some places that we've at our company have integrated with related to water data, and in one case, security cameras. And USGS and NDVC, National Data Voice Center, GLDW, which is our representation of data for consumption for building dashboards, they don't require any specific security, so they're wide open. And when you think about it, that's appropriate because this is public environmental data. I mean, it's not private data, it's not something to hide. Now, if you look at some of the instrument vendors that we integrate with, they all have some level of security on it, because in reality, they may not want everybody in the world, somebody may be wanting to use their data, but not make it public. So if you look at NextSense, I believe is the company, and their site is WQ Data, they only allow people to get their public data, and you need to know a site number and a parameter ID. So you need to, if you wanted to get data, say for Toledo, Regional Science Consortium has a lot of stuff that's using NextSense equipment, and you can get all that data. And we can get data from, for example, the Northeast Ohio Regional Sewer District from their station. And we have ways to do that with GLDW. But you need to know their site and parameter IDs, which are not publicly known. So it's not security, but it kind of obfuscates or makes it a little different to get that. Flume, which is a meter that monitors internal water usage, you have to set a token in a header. So setting tokens in a header is not trivial for all folks. It's not that hard either, and people that know how to do all that, they can figure it out. But sometimes just figuring out is kind of challenging because the documentation may suggest it one way and you kind of have to play with it. HoboLink and Onset, which a lot of the metro parks and many others have stations that use that, you need to set a password, a user, and a token all assigned to you. And you need to actually post it. Now, many of you may not understand the differences between different type of HTTP methods, but post is would be a little inherently more secure than using a GET. All these others use GETs. Streamlabs is another where you have to set some kind of ID in a GET header. And I believe there's no password on it, but it's just a way that it's hidden in the header, so it's not exactly trivial to kind of hack the data and it provides some level of security. Hi-Fi, which is a project that's and is currently by Brandon Wong and the Hi-Fi, I believe it's the company. They're putting out a lot of little remote water sensors, and they have good documentation on how to get the data, but you need to set a key with an ID that's been assigned to you. So you have to register, and then you can put that in the GET header in a particular way, and it'll return the data. And finally, just throwing this in there because I found digest authentication really difficult to do and very challenging. But some of the MCREST security cameras, and I imagine others, use something called digest authentication, which takes a couple of exchanges back and forth, and they hash things and they hash this, and it's quite messy and nasty. But anyway, what makes it difficult to get public water data is, primarily the metadata that you need to interpret, and secondly, the security things that may occur. And fortunately, a lot of places are not trying to be overly robust in putting in security, because in reality, they realize this is public data and we're not trying to hide anything. Any questions about any of these in specifics or any comments at this point? So what does GLDW do that makes this a little easier? So GLDW converts data from all these sources, and it takes care of the security and metadata. So it puts it in our very simple and public API format. Now, in some cases, if somebody's using a Flume device, which is for monitoring home water usage, they may not want it public. But in our case, we provide the option that if you use our components, you can make it option. And they're really ridiculously easy to access, and they're simple and optimal APIs, we believe. The other advantage that we have in the GLDW APIs is that we can provide aggregated data. So what that means is, suppose you have data from the USGS that regarding, say, the phosphates that are going into Maumee River, and at the same time you have some NOAA data, NDBC data that shows some kind of water quality parameters, and you want to kind of look at those together and process those together to do some kind of correlation. We can return both of those. We have good algorithms for putting the two things together in the same chunk of data. So, not to sell that too much, but then we go back to the challenge. All right, what is the challenge? We're saying that there's a lot of, let me go back up. We're saying there's a lot of water quality data that's out there that's not being used very effectively. And the challenge here is, let's figure out how we can take that data and make it really pop for people, and give it a lot of impact, and really educate the public or help scientists or give insights in any way with that data. So going back down here, the question is, if you wanted to get data for whatever purpose, either to accept this challenge or for anything else, you have different techniques that can work in this challenge time frame. And I'm not pushing one or the other. So you can build data access to the desired source, and in some sources that's not so hard, that handles security and metadata issues. If we happen to have existing adapters, and we do for some instruments, or for two major instrument brands, and for USGS and NDVC, you can have us, we can put the data in there, or it might already be going into GLD data, and then you have just like ridiculously easy access to it. For sources without existing GLDW adapters, you know, we, as part of this hack, we're looking at expanding our list of those. So if we find one that, say, your hack team or somebody else wants to get access to, that might be an option. I'm not pushing one option over the other, and we don't have, you know, a lot of capacity, a ton of capacity for C. And we will help coach and help you regardless of which approach you take. So if you wanted to tackle it by handling the metadata and security issues, we can help give you sample code and approaches that might deal with it for that particular source of data. Now, from a standpoint of dashboards, we recommend two options. One is building dashboards in either HTML and JavaScript and R. And we'll be providing support for that in further workshops as to how, you know, you would create a simple dashboard in R or a simple dashboard in HTML, and how you might plot with it and that kind of thing. So we're going to follow on workshops. We're going to be giving some help in supporting you as to how you would do that if you happen to be somebody that's not already kind of a really hot programmer and, you know, don't really need that kind of help. But we, you know, in addition to helping you develop access to the data, we can also provide help in how you would process the data as it comes back. And that's obviously an issue of how you would process. And we'd emphasize JSON because we think that's the standard. That's where people are going with it predominantly. Our next workshop will be about processing public environmental data. So we'll actually give some sample JavaScript in our programs that process data coming back using and with emphasizing JSON. And you know, so this will actually get in the point where you have a dashboard, or you have some code that you can actually get data back from a public source and begin working with it. So I'm going to stop it there and ask for any questions or comments. And I want to reiterate that here's my contact information. Absolutely feel free to contact me for assistance in any fashion. And if for some reason, if you have a team where it would benefit from having a development server, we are going to provide up to 3 development servers for teams where they, a Ubuntu server where they can do what they want on it. We're going to primarily focus on people that are doing our challenge. But if, you know, if your team needs that kind of support, let me know. We will be keeping kind of regular kind of office hours if you want to bounce ideas or bounce concerns about how to grab data or what problems you might be running into with getting data from a particular source. And, you know, we want to work, you know, we can work with you on that. So that's about it. We'll be having the workshop next week. We'll be announcing open help sessions for people that want to get help getting data. We don't want to get too involved in displaying data. We don't want to get too involved in writing code or, you know, helping with just any kind of coding problem. But if it has to do with getting data, you know, we're experts at knowing all the little tricks for, you know, trying to deal with the security issues with different types of data sources. So that's about it. I'm going to open it up for questions. And so, you know, feel free to enable your video and unmute if and ask questions.